Hello everyone, welcome once again to another Power BI tutorial by Team Slides 4. In this part, we are learning about creating an interactive dashboard which is called Food Price Inflation Trends in USA. Here you will learn creating these DAX measures. So for lower inflation here, least volatile category, max CPI change, most volatile category, we will learn all these DAX codes. And we will also learn how to create this interactive dashboard which is showing yearly CPI trend, which is showing average CPI percentage change, highest inflation year, lowest inflation year, all are calculated, most volatile category of food and least volatile category in terms of inflation, and average forecast percentage change by month, which is a heat map chart which is not present by default in Power BI, how we can import it from external app source. I will explain you, and how to create a ribbon chart to understand average forecast percentage change by month and the attribute value, which is basically the uh, kind of prediction interval like upper bound or lower bound or midpoint of prediction interval. I will explain the entire data set to you. So now let's get started with it. So the data set that we are going to use in this project is this CPI inflation analysis and forecasting data set that can track inflation and market trends with detailed consumer price index data for different food items. And we can get it from this particular URL on Kaggle. I will provide you the link of this data set in description. From here you can go and simply download the data set, and here you can see we have the file. So let's see the file first. So when you will download the file, you will see this CSV file here, and in the CSV file you can see we have these columns, right? So first is the consumer price index item, which is a categorical data like all food, dairy products, egg, fish and seafood. Then we have month of forecast, year of forecast, year being forecast. Then we have attribute like lower bound of prediction interval, midpoint of interval, and we also have the forecast percentage change. So here we have provided a detailed description of the data set and its potential analysis, like what you can do with the data set. So we have given some sample projects here that you can create using Power BI, Excel, or whatever your favorite BI tool is. So this data set contains consumer price index forecast data for food items in the USA from 2002 to 2023, and it consists of 41,624 rows and 6 columns. 6 columns are consumer price index item, the food category, month of forecast, year of forecast, year being forecast, the year for which the forecast applies, and then attribute, the type of forecast data. That means lower bound, upper bound, midpoint of prediction interval, etc. And then forecast percentage change, the predicted percentage change in the CPI. Potential use cases are inflation trend analysis. That means you can analyze CPI trend over time for different food categories, compare forecasted versus actual CPI changes if actual values are given. Then category wise price fluctuation, identify which food items have the highest or lowest price volatility, compare inflation trends across different food categories. If actual CPI data is available, compare the forecast with real outcomes. Then you can also do seasonal patterns, like investigate whether food prices show seasonal trends higher in certain months. And you can also analyze economic impact assessment, evaluate how CPI fluctuations affect consumer purchasing power, and analyze the correlation between food price inflation and macroeconomic factors, like if this data is available. Obviously whatever is available, now we will try to create a simple dashboard that can help you in understanding the steps that we are going to perform, and we will use some of these cases. Next is open Power BI desktop and connect the dataset. The dataset is available as a CSV file, so we will use the text CSV connector here and locate wherever you have saved your dataset and load the CSV file. Now once the CSV file is connected, you can see match all the columns are properly aligned with their headers, like header names are properly visible. If it is the case, then simply load the data. Otherwise, you have to go to Power BI transform and mark first row as header, which we have shown in many videos, but here it was not the case. Now we have the data set ready, and we will give a suitable name to our dashboard here. So for that we will add text box, and in the text box we will write food price inflation trends in the USA 2002 to 2023, and we will simply use a font size like 28, make it bold, and we can also align it to center. Here choose any color right now. If you want to go with a theme, you can go to view, and from here you can select any particular Power BI theme that is available, and then you will be able to see the color available in that theme. But we are going with the default theme, and later we will change it if needed, so that everything gets themeified. Now we will select this, and here in effects, its effect settings, we will enable a shadow, a visual border, give a border color, and give it a rounded corner. So this way we will have a rounded corner like this, and we'll make some space from top. This is food price inflation trends in USA. And just for fun, if you want to add some icons here, you can add these are the ASCII code icons that you can use here. So just to make your graph interesting, this is optional. I will provide you in a notepad. So I will provide you these item codes in the notepad so that you can copy and paste anywhere you want. Now our dashboard title is ready, and next thing is we will start preparing some KPIs. So to prepare KPIs, we will simply add card here. Either this card can be added as a KPI, or we have dedicated KPI visual available. So if your target value is available, like your actual value and your target value is available, you can use this. But for now we are going to use the simpler cards. We have dedicated videos on our channel where we have explained how to use KPI visuals. So you can watch those videos. It will give you great insights. Sorry for the noise. Now here we will simply add the average value of forecast percentage or change. So our first KPI will be average CPI percentage change, that is overall average inflation rate. And for that, what we are going to do, this is forecast percentage change. We will add in the field, and here we will select average. So you can see average forecast percentage change is 2.60. One more thing, in format visual I will disable the category label, and in general setting I will enable the title and give it this title, average CPI change percentage change. In your title you can make it bold, you can change the text color. Let's select something from the theme, let's align it to center, and if you want you can increase its size 15 pixel. Here your visual values are 45 pixels by default. If you want you can make them small or larger depending on your usage. So now we can use it like this. We will display 4 to 5 KPIs. So this must width is okay. We will again go to format visual and here enable some effects like this. So let's try, go to home tab, select this, format painter and apply here. Let me try one more time. So you can see it is applied. The only thing is title is disabled. So maybe we have to write it again. Now we will simply copy this. So it will be easier for you to learn. Now we will simply copy and paste 3 or 4 times so that we can create our KPIs here. Now let's see what next KPI we can bring because we have year being forecast. Now next we will try to create a KPI highest inflation year with maximum CPI increase. Now this is something, for this we have to write some DAX code. So I will provide you this DAX code as well. So let me create something and then I'll explain you. Now the first code, we have to create a measure that is maximum CPI change. In the forecast, let's say we will select this. So in our CPI data set, obviously we have percentage change, but there will be a maximum value for forecast percentage change. So you can see here, you can sort descending and you can see forecast change maximum value is 62.3 in the year 2023, right? So what we can do here, obviously we can write that, but we have to learn everything. So we will go to modeling and create a new measure, and first we will find out the maximum CPI change. What is that value? Now just for reference purpose, just to see, we will see that value and you can see it is coming as 62.30, which is correct, right? So now the first part is done. Now the next code, let me explain. To find out highest inflation year, we will create a variable called max CPI. Like what is the maximum CPI? So this is maximum CPI dataset forecast change, right? We already have this, but just to explain you. So we will calculate this and then we will return selected value, that is CPI dataset year being forecast, and calculate maximum CPI dataset for year being forecast. So it will, in selected value we are using the year being forecast and we will calculate its maximum value, and CPI dataset forecast percentage change is equal to maximum CPI. This is the filter. So let's first try this whether it will work or not, otherwise we will alter this. We'll again go to modeling tab, new measure, and here you can see. So here you can see selected value year being forecast. In selected value you have to first select a column name, return the value when there is only one value in the specified column, otherwise returns the alternate results. And then we have the alternate results like calculate maximum CPI dataset year being forecast. So this is the, we are using calculate function. In calculate function you select an expression which can be minimum, maximum, sum, etc. So we are using maximum because we have to find out year in which the maximum change was there, and then you will use your filter like in the dataset maximum CPI. So let's try, and let's try what we are getting here. So when you will drag, sorry, highest inflation year, you can see 2023. So this is something that we can do. Similarly, if you want to find out for minimum, right? Let's say we are just doing it like in which it was minimum. So you can see in 2024 it was minimum. So maximum, minimum, or any particular value you can use here. So we have the average CPI percentage change, and now we have our calculation ready. So we will use highest inflation year, and highest inflation year is, first of all, in title we will write highest inflation year, and here we will simply replace it with highest inflation year. There are easier ways to do that, but we are just using this method. Okay. Now let's try our third KPI, and before that, don't forget to save your work. Saved it as CPI analysis. Now third KPI, which I just explained, is lowest inflation year, and for that I will simply use the same formula again. For lowest inflation year, we will simply write the same thing. Like, you can fast forward this part. So here we will create min CPI and write minimum here, and return selected value CPI data set, calculate minimum forecast, and we will use the same variable like to apply in the filter, because in selected value this is something that you have selected or the alternate result. So we are going with the alternate result. Again we will create a new measure, lowest inflation year, and I will just copy this part, and here I will simply replace it with lowest inflation year. So we have average CPI percentage change, in which year we had highest inflation, in which year we had lowest inflation. And again, all of these values are from this data set. So we are just assuming that this data set, whatever is given inside this data set, we are analyzing. So please make sure that, and this data set is from Kaggle, so you can do more research and get correct proper data to see the proper values. Now the next KPI that we have to find is most volatile food category. It is category with highest price fluctuations. Before that, we will understand definition of volatility. So volatility can be measured using a standard deviation of the forecast percentage change for each food category. A higher standard deviations means greater price fluctuations, because when prices are changing, right? So in a category where forecast percentage will be fluctuating higher, so that means it will have a higher standard deviation and vice versa. To find that, we will use the calculate function as we did in the earlier case. In calculate function, you write your expression and then you write your filter. So first we are using a standard deviation population of CPI dataset forecast percentage change that we have used here. Then we are using all except. So in all except, you first provide the name of your table and then you provide the column name. So all except ensures the calculation is grouped by consumer price index item, which in our case is the food category. Okay, so here is something that you use to group by, because whenever you are applying aggregate value, so you have to group the data, and we are grouping by the food category, which is price index item. So let's try if it will work. So we will go to modeling tab once again, new measure once again, and category volatility. First of all, let's try that. So you can see category volatility, and here you can see standard deviation wise we are doing that. Now after finding out category wise volatility in a measure, what we are going to do, we will find out most volatile category. But before that, I want to show something. Let's say we take a stacked column chart. Although it will be easier for it will be easier that we just added a field and selected the measure when we have to show it in a visual. So on x-axis we will select the category. Okay, this is consumer price item, which is category, and here we have the category volatility, which we will bring on y-axis. And you can see, just to confirm, that eggs have the highest category volatility, and we can select this formatting and apply here. Okay, so this is category volatility by consumer price index item. So this is one thing that we can do, which gives us an indication which is that category. But in order to do it programmatically, here we have the most volatile category. So to do that, first we will create a variable as we did earlier. So maximum volatility will be max x. We use max x when we have to do row wise calculation. So we will use all CPI data set and select category volatility. So let's copy this and go here and in modeling and create a new measure. So here in max x, okay, let's see the definitions. So in max x, first you have to write table, and it returns the largest numerical value or largest string that results from evaluating an expression for each row. That is the meaning of max x, right? For each row of the table. And here we are using all function. So we have specific videos for all these functions in DAX, but I will explain you an overview of this. So in all, we select a table name or column name, and it returns all the rows in the table or all the values in a column. Since we have selected a table, so and we will select the category volatility, that is the measure here, ignoring any filter that might have been applied. It will return, and now we are doing the same thing as we did earlier, selected value. So we will select the consumer price index item, and we are calculating maximum CPI data set. So this is the value. So we are selecting maximum category here, and where category volatility is equal to maximum volatility. Okay, so this means this value 14.22. So when you will do that, let's see what the issue is here. So here is the change code, because we were finding out a text value. The calculate function was not working, although it worked correctly in case of numerical value. So now here we are creating a maximum volatility table as a variable. We are selecting top n, that is top one, and summarizing. In summarize, we select a table, this table, and then we group by a column, that is the group by column here, the category column, and we are using the name as volatility, and then the value for expression that we are writing is standard deviation population CPI dataset forecast percentage change, whatever is the standard deviation. So it will write the category name and its standard deviation for from the forecast change, and then we will give output as volatility, and then from this table we will return maximum of this particular table, CPI dataset consumer price index item, the category that is on the top, because we will have only one category. So let's try this way, and here we will have maximum volatile category, that is X, which confirms our calculation. So this is maximum or most volatile category. So we will simply rename it here like this, copy the name and go to title, and we will have most volatile category, or we can give a better name also. So first I will update the correct code, because after trying several times we get the correct value. Now we have the most volatile category. So the KPI that we wanted to do was most volatile food category. You can write it as most volatile category or food category, whichever is your preferred title. Similarly, if you want, you can also do least volatile food category. Like here, you will just create least volatile category and create a variable. So here you are summarizing. So let's try that. So we will create a new measure and we will call it least volatile category. We will use top one, this, etc. We will just write ascending, and we will here write min volatile table, call it as min volatile table, and we will select the consumer price index item. So let's do that. As per our chart here, the least volatile category is food away from home. Let's write this, and here we will bring the least one. So least volatile category, food away from home. Obviously here we need to change the text size. So for this value we will just reduce the text size so that we can see properly. Food away from home, and it will be least volatile category. So something that you can do as a calculation, if you want to create more KPIs, there are ways like for example, how many total items are there, unique number of items, uh, different attribute values are there, what is the as we have done average forecast change, we can do minimum forecast change, maximum forecast change. So this is something that we can do, but we'll keep for this dashboard, we will just keep it like this and align them evenly in the top row. So now we have some KPIs and we have calculated or we have created a chart here. This chart is a stacked column chart, and in the stacked column chart we are trying to show category volatility by consumer price index item. In this chart, if you want to show these values, you can go to format setting and enable data label. You will be able to see that value as well. Next is we can try line chart, that is yearly CPI trend from 2002 to 2023. So let's do that. In x-axis we will drag year, and on y-axis we will drag the CPI percentage change. As a legend we can add different food categories. So let's do that. So we have a line chart here. First of all, what I will do, I will simply copy the formatting and apply here. In x-axis we have year of forecast, so let's drag year of forecast, and in y-axis we can bring the percentage change, so forecast percentage change. So you can see year wise, and we can see the maximum change is in 2022. Here it is being shown as sum, we can do average, so you will get average percentage change here. Okay, now if you want to show for different food categories, although there will be many lines, right? So we can choose here like consumer price index, sorry, we can choose price index item to legend. You can see there will be many lines here, and since there are many lines, obviously we can give an interactive filter here. So we can drag a slicer here, and since there are many values, we will use a drop down value. So we will adjust it like this, or maybe this 1/3 of height, and here we will drag the category. We will go in settings, slicer setting, and select as a drop down. So now you can see we have a drop down here. Let's select two of them, so you will be able to compare them, right? Or if you select three of them, so you will be able to compare their volatility by CPI, item wise category volatility, and you will be able to see average forecast percentage change. We will simply rename this as yearly CPI trend. Now here also we will apply the same formatting, and so that it has these borders, and in values we can increase the values size a little bit and increase its height so that one has easier access. And this is food item, right? So we will go there and disable the slicer header. In general we will write the title food item or food category, whatever you want to write. So this is food category, and then whatever value you will select, if you will select for all food, you will see here. We can also show a select all button here. So in slicer setting, in selection, you can select a show all button. So you can select all and you will be able to see for all food categories. Okay, if we select 5 or 6 of them, then you will be able to see for those values. If you will zoom it, you will be able to see trends for different categories that you have selected. Next, we also have month of forecast. So for example, what we can do, we can bring the month of forecast here. So instead of this, we can use month of forecast as a filter. So let's say we want to see in August, in December, in February, you will see the most volatile category in that particular case and least volatile category. So we will try to use the same size for both of them because their values may be different. So let's try 25. What we have selected 16 here. So we will go and select 16 here as well. So this will be that, and so it is showing for January, and here we have selected multiple values. Okay, and here we can change the title. This is forecast month. We have already done clustered bar chart, that is category wise CPI change. So but we can do it one more time. Like on x-axis we can drag food category, and on y-axis we can drag CPI percentage change. So this will identify which food item experienced the highest or lowest inflation. Here what we have done, we have dragged the category volatility. So suppose we want to keep it like this, so we can select a line and a stack column chart, which will not make any difference here, but we will have an extra line y-axis, and in this extra line y-axis we can drag the forecast percentage change. Like earlier, the value that we are showing here is a different unit, which is a standard deviation, and here we will simply show a percentage change, so which will show as a line. So you will be able to see deviation and in which category we have the highest forecast price change, right? Percentage change. So here we will choose average. So when you will choose average, then you will be seeing these values like this. Obviously it will be lower than deviation in most of the cases. So this is something you can select from here. If you want, you can select all and you will be able to see the line. Now since we have too much data here, so first of all we will adjust the title here. Okay, so this will be food category wise volatility and percentage change, or we can simply write percent change. You can give a better title as well, but here we are writing. So when we'll apply this title, obviously you will see we have more space here. And since we have too many values, we will go to visual and disable the data labels. So now we will have a cleaner graph here. And this is only for the January month. We'll select for all months. So you will be seeing like in eggs, what is the category volatility and what is the actual value of percentage change. If you want to master data visualization and business intelligence using Power BI, then you can go to our Power BI course tutorial for beginners on Udemy, where you will learn Introduction to Power BI, core concepts and its features, data import and transformation, advanced DAX functions, data modeling. Many practical projects are there, and Power Query Editor and its usage, and creating dashboards on different data sets. So here in every section, you will get all the chapters that are needed to master Power BI. So I will provide the link of this course in description so that you can visit and check out this course. Now, let's say we want to show a month of forecast wise forecast percentage change. Okay, there are a lot of ways of doing that. Like we can use a donut chart or we can use a stack column chart, but we will try a table heat map here, right? Just showing you use of different visuals so that you can use it whenever you will need it. And here you will, how you can get that. So this is a website called appshost.microsoft.com from where you can get additional visuals that are not by default there in your Power BI. So from here we have searched table heat map. So you will just go to this site and search heat map or table heat map, and you will get a lot of visuals like heat map visual, heat map, etc. We are basically selecting this one which comes from Microsoft Corporation, and it is free and you can get it now. So if you have a work or a school account, you can sign in and it will start downloading. Okay, you can also download a sample, so it will give you some Power BI file where you can use it. Now here what we can do once it is downloaded, so you can go to your Power BI report and click on get more visuals and import a visual from a file. It will give you some caution that custom visuals aren't provided by Microsoft and could contain security, privacy risks, etc. You can read that, but I'm going to import. This is from Microsoft itself, and here I have downloaded some visuals, and this is the table heat map. So in table heat map, we can drag two or more uh, different numerical values like forecast percentage change or year being forecast, something like that, to create a heat map. So we will simply update this. Import was successful. Now let's drag a heat map. First thing we will try is using format painter, apply the same styling. Now here it will show you two options, category and Y. So in category, I will drag the major categorical field that we have. Here we can either drag consumer price index item, but we want to see monthly, right? So this month will also work as a category for us because it has these 12 values. So we can drag this month being forecast as or month of forecast as category, and on Y axis we will bring forecast percentage change. Now what it will give you is it will arrange the data like this. So here you can see on this heat map table the columns are all months. Here we have some value which is sum of forecast, so we will make it average. So this is average of forecast percentage change. So you can see if the value is in the lower range, it is lighter. So you can see in August, January and July the forecast change average is lower as compared to June, May and February. So based on this analysis, you can try and do your calculations. So this is average forecast percentage change by month. Right? We can go to title and we can write something like this. So this will be average forecast percentage change by month, or forecast, or you can simply write by month, whatever you prefer. Okay, so this way you can create a simple heat map, and this is a good way to analyze because it will give you the color gradients also. Now if you had other values like price, etc., so you can drag them to the y-axis and it will create a better tabular structure, so which you can see here, right? For example, here you can see this is year, or one of this chart where you can see we have some value here, and April, August, so we have month as category, and then different years, some value in those different years as a value. This can be used for user retention analysis, etc. as well. So this is average forecast change by month. Next, we also have another important parameter, that is attribute, which is upper bound of forecast range, lower bound of prediction interval, etc. The next visual that we can show is a ribbon chart, which is best for showing ranges between forecast. So we have a column that is attribute, upper bound of prediction, midpoint, etc. So what we are going to do, we will use a ribbon chart. On x-axis we can bring time, that is year or month. On y-axis we can bring CPI value, since we don't have the value but we have the percentage change. And in legend we will bring the attribute. So let's try that. You can copy, change it to ribbon. On x-axis we will bring year of forecast. You can also bring year being forecast if you want. So we have year of forecast, and on y-axis we will bring the forecast percentage change. So it will show same as it did in the case of line axis, but here's the catch: in legend we will bring the attribute, right? And attribute, like, which will show us the trend. So here you can see, on here you have the lower bound of prediction interval, you have upper bound of prediction interval here, and you have the upper bound of forecast range and middle point of forecast range. So in every range, every year, you can see this. Now what is this showing us? When you want to visualize forecast uncertainty with clear banding between upper and lower bound, or the mid bound that is given here. So this is a simple chart that will represent that data. So this is our food price inflation trend in USA. Simple interactive dashboard that will help you in doing this type of analysis. Now, since we have added these things, we can also add year being forecast as a filter. So this is year being forecast, and similarly you can also bring year of forecast. So now you can try all the filters and see, like for example, we select for eggs, dairy products, fats and oils. We select for forecast month of August and December. We select for year 2004, 2005 and 6, and year of forecast, it will be 2006, let's say, or 2005 and 4. So this way you will be able to apply all filters and see food price inflation trends. I hope you like the tutorial, you understood the most of the DAX that we have created. If you did, please like and subscribe. Like this video and subscribe to our channel so that we can bring more videos like this for you. Have a nice day.